Hello, how are you guys doing today? And it's Jalaj Aurora here again, back with another video from BHM at GCSE Chem. And today we're going to be doing section C1.6, which is all about the structure of the atom. Now, a couple of things before I start is that firstly, yesterday we did obviously C1.5 history of the atom, and in the book it says, you should describe the plum pudding model as negative electrons which were embedded in a ball of positive charge. Now, one thing I would like to say, I think it's better to actually say negatively charged electrons that were embedded inside a ball of, or in a ball of positive charge, instead of just saying negative electrons. I know what you mean. I know what negative electrons, it's not much of a difference, but sometimes, just to make sure you get the full marks, I would personally say negatively charged electrons embedded in a ball of positive charge, instead of negative electrons embedded in a ball of positive charge. Because from my own experience, actually, when I started A-level chemistry, we had a kind of first 2-chapter test, and they asked in one question, what is the charge of a proton, for example, and obviously it's +1, but I kind of, I thought, 1 would be sufficient enough. But then when it was marked in the mark scheme, it specifically said +1. If you didn't put that plus, you didn't get that mark. And I would, if you asked me that question any day, I could tell you +1. It's just because I didn't write that plus in the test that I did, I lost that mark. And unfortunately, I think it was, I don't know, it cost me like a grade. I don't know what it was, but yeah, it was quite, changing. I think it was only like one test, but it was only, it changed my grade by quite a bit. But basically what I mean is, don't kind of, always try and write negatively charged, I say, for electrons, because you never know, the mark scheme, if you have a nice examiner, they might give it. If you don't have a nice examiner marking your paper, and you never know which type of examiner you have, or it's not only on the examiner even, it's like the mark scheme as well. If they specifically say negatively charged, then you're probably going to have to write negatively charged. But basically, I think it's better to write negatively charged anyway. Like you have to write charged, I'd say, in my opinion, even though it says negative in the book only. But I'd say negatively charged electrons. Anyway, moving on from that, today we're doing C1.6, which is the structure of the atom. It's a very basic topic, so should be a good one to do, and should be done relatively quickly, because who doesn't know the structure of the atom? It's quite a simple topic. And so let's start. So the nucleus at the center of an atom contains 2 types of subatomic particles, and these are, before I start, I just stopped myself in the middle. But before I start as well, C1.5, when I did the history of the atom, now I'm not sure if I said J.J. Thomson or J.J. Thomson, but basically his name is J.J. Thomson. So the spelling is, if I just get it right again, wait 1 minute, if I just get this right, because I don't want to give the wrong kind of information, it's Thomson. Now, I might have said Thomson in the video, or I might have said Thompson, like it's, but remember it's Thomson, Thomson. So Thomson, yeah, cool. And so now we're starting C1.6. Sorry for the delay a bit, but basically the nucleus at the center of an atom contains 2 types of subatomic particles called protons and neutrons. Now, protons have a positive charge and neutrons have no charge. So we obviously know that protons have a positive charge, neutrons have no charge. Electrons are negatively charged particles that move around the nucleus, and an atom has no overall charge. And there, this question is actually quite common for like 2 marks. Why does a neutral atom have no overall charge? And the reason for that is because the number of protons is equal to the number of electrons, and their relative charges are equal and opposite. Proton +1, electron -1. So even here for proton, they've wrote +1. yeah, so it's important to write the plus, I guess. Yeah, so basically the number of positive charges equal the number of negative charges, so the number of protons equal the number of electrons. They have equal and opposite charges which cancel each other out, which balance each other out, and therefore you know that atoms are, you know, an atom has no overall charge, it's neutral because of that reason. All atoms of an element contain the same number of protons, so you know, an element basically is defined by the number of protons it has. If it has different number of protons, it's a different element. You know, the number of protons of a specific element always stays the same. Like for example, carbon, and you know, every element that basically, or every atom rather, that has 6 protons in its nucleus will always be carbon. Will always be, you know, an atom of carbon. Yeah, so that's an example, because carbon's atomic number is 6. So now we get on to, obviously, all atoms of an element contain the same number of protons. This number is called the atomic number or proton number of the element. So atomic number is the same as proton number. So the number of protons of the element, basically, of the element. Elements in the periodic table are arranged in order of their atomic number. Now this is something that's quite overlooked, but it is kind of a question that does come up as well. How are elements arranged? And the answer is they're arranged in terms of increasing atomic number. You know, they're arranged by their proton number, basically atomic number. And or you could say they're arranged by increasing atomic number. That's a better way of putting it. Saying it. Elements in this periodic table are arranged in order of their atomic number, so that's important. Yeah, the atomic number is also the number of electrons in an atom of the element, because obviously, you know, if an atom is neutral, the number of protons equals the number of electrons. Because, to be honest, if an atom is not neutral, it's not an atom anymore, it's an ion. And we're going to learn about ions and isotopes and, you know, other things in the next section, ions, atoms and isotopes in C1.7. But for this section, we're just assuming we have a neutral atom, and therefore we have a number of protons equals the number of electrons. Therefore we can call the atomic number the number of protons, which is the same as the number of electrons. But if they in the exam, if they're asked to define the number of if they're asked to define atomic number, don't say it's the number of electrons. Just say it's the number of protons in the nucleus of an atom, because, you know, the number of protons only equals the number of neutrons if the atom is neutral, basically. Kind of, yeah. If you have ions, then, you know, they're not. There's an imbalance of positive and negative charges of protons and electrons. So I just say atomic number is the number of protons in the nucleus of an atom. Just say that, and you'd get the mark. It should only be a 1 mark question, really. It's not that hard. Elements in the so there, what I said that there. Okay, the atomic number is also the number of electrons in an atom of an element, but don't define atomic number as the number of electrons. Just know that for a neutral atom, the atomic number equals the number of protons, which equals the number of electrons in a neutral atom. Now the mass number is the total number of particles in the nucleus of an atom. In the nucleus, remember, only protons and neutrons reside in the. Is reside the word? I think, yeah, basically only protons and neutrons are in the nucleus of an atom. So therefore, you know, the mass number is the number of particles in the nucleus of an atom, and so it's the number of protons plus the number of neutrons, because electrons are obviously they are kind of in shells. They kind of revolve around the nucleus in energy levels or shells, so they're not in the nucleus. But yep, so here, for example, they, you know, substituting numerical values into equations. Work out the number of each type of particle. So they're giving an example here, basically. Work out the number of each type of particle in an atom of fluorine from its atomic number of 9 and its mass number of 19. So number of protons equals atomic number, which is 9, yeah. So number of electrons equals the number of protons. With obviously a neutral, we're assuming it's a neutral atom of fluorine, and therefore number of neutrons is the atomic mass, or the mass number, take away the atomic number. So mass number take away atomic number. I think mass number is better than atomic mass, but basically mass number minus atomic number, which is obviously 19, take away 9, so it'd be 10 neutrons, yeah. And then here's a question: how many protons, neutrons, and electrons are there in an atom of aluminium? Atomic number is 13, mass number is 27, so obviously atomic number is 13 means there's 13 protons, and it's obviously an atom, so it's neutral, so therefore that means number of protons equals number of electrons, so therefore there are 13 electrons, and then the number of neutrons equals I'd say mass number minus atomic number, which is 27 minus 13, so that means 14 neutrons. And yeah, we're nearly done. The keywords for this section are protons, neutrons, electrons, atomic number, and mass number. They're the keywords for this section. I probably should have said this before, but if you are following the student book, the pages today that we've done from the big book is pages 14 to 15. So it's 14 to 15 there. And now we're just going to finish up the video with just a few key points that are important to know. So I'll just get the book here again. Sorry I keep moving the book, it's just sometimes easier to see it this way, like over here, sometimes it's easier to see it there. So yeah, oh wait, did I show you the book that I'm using? I was meant to show you this on every video, but basically I've been using this, the GCSE AQA Chemistry, AQA Caboodle book, and yeah, that's the book I've been using. Apologies for not showing it before today. I don't know how I forgot, but basically, yeah, I pretty much show it in every video. So atoms are made of protons, neutrons, and electrons. We know that. These are the subatomic particles: protons, neutrons, electrons. Protons have a relative charge of +1. Electrons have a relative charge of -1, and neutrons have no electrical charge. They are neutral. Neutrons are uncharged. They're neutral. That's also why the nucleus is positive, because nucleus contains protons and neutrons. Protons are positively charged. Neutrons are they're uncharged or they're neutral. Therefore there are only positive charges there. So the overall nucleus is actually positive. I know I say positive. Positive, right. The relative masses of protons and neutrons are both 1. Now that's something that wasn't here, but you just need to remember that the relative masses, now this isn't the same as relative charges, there's a difference. The relative charges of protons and neutrons are 1 and 0 respectively, but the relative masses of protons and neutrons are both 1. Now, and for electrons, the relative masses, I believe it's 1 divided by 1,840 to be exact, which you can just say is 1 divided by 1 divided by 2,000, which is really, really small. The mass, the relative mass of an electron is so small compared to that of a neutron or a proton. Yeah, and then so atoms contain an equal number of protons and electrons, so they carry no overall charge. We've said that they carry no overall charge. They're neutral because they have the same number of protons as they do. They have the same number of protons as electrons. The same number of protons and electrons. Basically, they cancel out each other to leave a neutral atom. And then atomic number equals number of protons, which equals the number of electrons because the atom is neutral. Look, even here they've said wait 1 minute, I don't know if you can see it. Maybe I won't show it like that, but basically in here they've said atomic number equals number of protons, and then in the brackets they wrote number of electrons, because it does mean number of electrons too, but I think that means that they don't want you to say atomic number is the number of electrons. Very important to get that right. Atomic number is the number of protons in the nucleus of an atom. You won't get the mark, I believe. I'm pretty sure you won't get the mark if you say electrons, because that's not the formal definition. It's just that protons and electrons are equal in a neutral atom, but that isn't to say that atomic number is the number of electrons in an atom. Like, that's not the formal definition. Even though it is technically right, it isn't good to say that for the exam. Mass number equals number of protons plus number of neutrons, so we know that as well. Number of protons plus number of neutrons. So I think I'll end the video here, guys. We've finished the section C1.6, and tomorrow we will be doing C1.7, which is all about ions, atoms, and isotopes. Another pretty basic section, pretty good section. And just before I go as well, I just wanted to show you this. Basically, in the contents page, I put basically squares. You can see, like with pencil, I put squares around. Squares around things that are, you know, kind of triple science, GCSE chemistry only, because I know people do double science and triple science. So when I do like a section that is just for GCSE chemistry only, like for people doing triple science, I will kind of put it into the video title as well, and I'll, you know, let you know in the video that, yeah, this video is only for triple science students, so that double science students don't have to learn things they don't need to. But other than that, I think that's all for today. Make sure to share, like, and subscribe. You know, keep those notification bells on. If you haven't done it already, turn your notification bell on so you know when I upload a new video you can watch it. And yeah, that's all for today. Thank you very much, guys.